Long time no see. I hope you're doing great in these super strange times, but the topic is a little bit different today to what the world is talking about right now. So I got a new car and it's a Volkswagen, a VW, and this one had a stock radio in it. It was some super standard one, only CD drive and radio without any aux input or something like that. And then I changed it to a radio like this one. It's a radio with an Android system on it and a lot of video in and output and Wi-Fi and Google Play Store and so on. And the normal radios, if you ever had something to do with it, are having one voltage input which is always on the battery, so it's always on, always 12 volt, and one pin that is only connected if you put the key in and turn it, so it's the ignition input, I would call. So the radio knows when it needs to turn on and when not, so it saves the battery. And also another pin is, back then, for example, the light in the radio display, the LCD gets dimmed and the light turns on here on the knobs and the buttons when you turn on the light in the car. Unfortunately, many cars have now built it into the CAN system and only bring the CAN bus to the radio. When you look at this pin-out diagram of the quad lock plug, it's from the VW, you can see here CAN high and CAN low, but no other pin that connects, for example, the ignition pin. And that's where I started to play around with the CAN bus and look into what they do, what they make to get it work. I purchased another radio with this small box on it. It's a so-called CAN bus adapter box, like that, if it would focus. Yeah, like this. And this needs to be specific for the brand of the car, so it will get recognized the CAN messages that are on the bus that are transferring there from the car. Here is also this quad lock plug you saw on the image. I looked into it, I took it apart, and also I made a small adapter to listen into the CAN bus of the car, to recognize it a little bit and to see what it makes it turn. And I will explain a little bit about it. The CAN bus decoder is used to get the CAN signals, get it over a transceiver into a microcontroller. It then has 3 outputs that can be switched via some transistors here, some PNP ones. And it's for one the ignition, the light and the reverse pin. Also it has an RX and TX serial connection that is going to the Android radio to show additional information on the screen, like is the door open or closed. I wanted to imitate this box and make my own. So I purchased some CAN bus decoder. This PCB is super simple and works very nice and good. It's just about €1.50, so it's affordable. You have an SPI interface and on this side you have the CAN bus, and you can theoretically directly connect this to the CAN bus in your car. Most cars have 3 different CAN buses inside. It's for once the motor bus, the diagnostics bus and the comfort bus. On the radio is on VW connected the comfort bus, where data gets constantly written onto it, like the battery voltage, the RPM from the motors and so on. First I played around a little bit with the CAN bus decoders and just connected two Arduinos together, and here I made just a simple example of it. You have an Arduino Uno connected to the decoder, two lines of CAN wire, another Arduino Uno. On this side you have two buttons, and on this side here you have two LEDs. And if I now give power to it, these cables are just connected to a USB power bank. Both LEDs here light up, and if I press one button, one LED goes off, and if I press another button, the other LED goes on and off. This communication is totally done over the CAN bus, and it's just super simple. There is this one library I really liked, and I will put it in the description, so you can also play around with this. The only bad side of this is the CAN decoder uses around 9 milliampere to work. In addition, you have the Arduino Uno or the Blue Pill microcontroller and so on. The CAN bus box on the car is powered all the time, and if it would draw these 9 milliamperes, or in case of the Blue Pill it's around 40 milliampere for everything, this is a little bit high. So I thought about a solution to bring the power a little bit down, and for that the MCP2515 has a sleep mode, and if we look onto the data sheet, you can see here the standby mode, sleep mode, only uses 1 microampere. I tested it, and the power was really going down from around 9 ampere this PCB uses to around 5 or 6 milliampere. So the sleep mode was really working, but still it was too much. So I looked around a bit, and for once here you have the schematic of the PCB, and here we have the transceiver, which got this S connector, and this is connected to ground, and we have here this TGA1050, which unfortunately does not have any standby mode. So this one was the power draw in my test, the problem. I looked around a bit and found this TGA1042, which also have a standby mode with it. So it will hopefully save a lot of power. And to activate this standby mode, we can see here that we have to put the STB pin either high or low to bring it into standby or normal mode. So here you have it to ground. This would be the normal mode, and you need to put it high to get it into the standby mode. What I did then, I desoldered the stock transceiver and soldered the standby pin via a 10K resistor to ground. And if you follow this Dodge wire to this pin, you can see I just connected it there and let everything else be like it is. No additional wire to it to control the standby mode. The reason is we have here on the connector, this one is the correct pin out, we have here the RX1 buffer. And if we then look closer what this thing does, here is the register description of the RX1 buffer. So we can either use this pin as an interrupt output when the a valid message is loaded into the buffer 1 of the decoder, but I'm using it as a digital output pin, and I can simply control it via a register of the chip. So I just had to make this little botch wire and the additional resistor. Yeah, okay, I had to change the transceiver to get it into standby mode. And now my overall current draw is at around 1.7 milliampere, including the transceiver and decoder PCB and the blue pill board to in the standby mode. I then designed a little PCB for it, and here is this schematic. Here we have the blue pill board, a UART connection. This on the top is the decoder module, including the standby pin connected to the RX1 buffer. We have here 3 PNP transistors to give out the ignition light and reverse, 3 additional LEDs, and an LDO to bring the 12 volt from the car to the 5 volt of the system. This is also very power efficient, and on the blue pill board is an additional LDO to bring it from 5 volt to 3.3 volt. So the whole system can be used with 12 volts and still only uses 1.7 milliampere in standby mode. If some messages on the CAN bus here occur, it will wake up, because both of these chips can wake up, and will fire an interrupt to the blue pill that will then wake up. So yeah, I ordered the PCB from PCBWay, and these are also the sponsor of this video, and I am still waiting for the PCB. But for now I'm having no problems with them, and the shipping is very fast, even in these times right now. Here are some PCBs from an earlier project from PCBWay. Please check them out. They make really great quality for the price they are offering. It is just at $5 for 10 PCBs, up to 10 by 10 centimeters, plus shipping. And yeah, I really like to work with them, and I am psyched to get this new PCB and to solder it together and play around with it. Here I am now in the car itself. I have installed one of these Android radios, and as you can see, it's just having the normal Play Store and everything else you imagine. I installed this little plug here on the top. It's a simple 2-pin connector, and I can plug this one here into it, and it now goes to the CAN PCB and to an Arduino Uno or Nano, and then to the PC, where I will show you what you can do with it. The plug itself is just going straight to the CAN high and CAN low pin, and yeah, if I connect it and start the computer, you can see what's happening. I have the plug now inserted, the car is running, and it's connected to the Arduino Nano and then to the USB port, and I have opened the software called CANhacker and connected to the Arduino Nano. We can here now see a lot of messages appearing, and we see the counter, so it's going up very fast, and also in which period, so it's just sniffing the CAN bus data. We have at the front the so-called CAN ID. We have the lengths of the bytes that are coming. You can see here. And then you have the data itself. And then the set period and also the counter of the message. So how often was it received. And I looked around a bit and decoded which message is. For example, the 571. Here, these 2 bytes. This is the battery voltage of the car. So if we convert it to an unsigned int, we can multiply it by 0.05 and add 5 to it. We have the current voltage. Also on the top, the message 353 here. This is the current RPM, these 2 bytes of the car. So if I go onto it and view a little more details of it, this software is quite nice for it, and I press the pedal, you can see this part is going up, but in reality it's still there. The bytes are not correctly calculated as they should, but you see what I mean. Another part is here also. For example, if I let go the handbrake, you can see that the message 621, if I click onto it, that the fifth byte is getting high or low if I pull the brake or not. So you can decode it in bit form. Also, if I press or go into reverse and click that away for a moment, I have to look into what is changing now. Okay, here on the top. If I look into what is changing, you can see that the second bit from the first byte is getting high or low if I go into reverse or not. The next thing is also if I open the doors. You have this message here, the 621. And if I open the door now, you can see the bit is changing. And so it goes on and on. You can also send a message here on the bottom to send it back onto the CAN bus. I didn't got much to work, but some cars also have a display here in the speedometer, and you can display some data, for example, on it. But this car had not one there. This is the library I am using for the CAN interface, for the MCP 2515. And it is really nicely made. As you can see here, it has the schematic I am using and all the descriptions you need to get it working. It has also nice examples on it. And there I also found the CANhacker software. You see it here. So if you click on that link, you have the Arduino file you load on the Arduino Nano or any other Arduino, and you then need to install the MCP library and also the CANhacker library. And also you can use the CANhacker software here as I am doing it. There's also a CAN reader, so that's an Android software for it. This is not well developed, so the PC software is definitely better. But both is open source, so you can change it to your need. I also did a fork from the MCP library to change a bit in it. For once, the standby mode is a little bit different. And also I made the standard frequency of the external quads of the MCP, as you can see here, to 8 MHz. You have to select it when calling it, like here, otherwise, if it would focus. Yeah, here. Here you can see the go to sleep mode for the transceiver, so it will turn the RX buffer pin to high or low. This is the thing I added to the library and the reason I forked it. Okay, that's it for today. Unfortunately, I cannot show you the PCB right now, as I'm still waiting for it myself, but when it arrives I will show it in working condition to replace this not compatible CAN bus box for my car. And I hope you like the tip with the standby pin to bring it into a low power mode. So if you have any CAN system you want to use in a low power system, you can make it work exactly like that. Or you can also, of course, make your very own PCB to have it not with the botch wire. And yeah, stay safe until next time.